Welcome to Arduino series by Dreadnought Robotics.
Hello guys, today we'll be seeing about introduction to Arduino. First of all, Arduino is a development company that produces development boards from Italy. These development boards are used in numerous ways to make our life easier in automation, in robotics, in sensing techniques, etc. So, introduction to Arduino. Basically, there are lots of Arduino boards like Arduino Uno, Mega, Nano. The most commonly used board is Arduino Uno. In Arduino Uno, there are lots of features. The main thing control is because of this IC, that is 8ML80 Mega 328. This IC controls all the inputs and outputs and all the transmission that occurs here, all in digital logic. So first, the USB jack. This USB jack is used to power as well as to provide serial communication, that we'll be discussing further. And this is the RxTX pin for communication using serial communication, we'll see it further. And the LED, this is the main LED. This LED is linked to pin 13 of digital. So whenever this pin is triggered, this LED will glow. And the power LED. This power LED indicates whether the board is powered on or off. This is a DC power jack with an adapter that you can power this board externally when you are not uploading the code. Once you are done uploading, if you want to use it somewhere else, you can use this jack, power it and run it. Now coming to the pins. These are the digital input and output pins with a ground here. In some of the pins marked in number 1 here with a dash. Those pins are for pulse width modulations that we'll be seeing further. And here this is for digital, and this is for analog input output pins, like the for analog devices like a potentiometer that give a varying output signal. And here you see there are two grounds, V input, 5 volts out, a power supply, 3.3 volts power supply, reset pin. And this button is a reset button to reset the Arduino board. And these are voltage regulators, 7HLC voltage regulators, all other features. Now, getting started with the interface. Arduino is an open source environment, IDE. It can be downloaded from Arduino.org based on your necessity of your computer, whether it's a Mac or a Ubuntu or Windows. Preferably go for Windows, in which you can easily initialize the COM ports. Now, I'll show you how you launch it. Once you launch the Arduino IDE, this thing pops up. Maximize it or minimize it. Maximize it or this is a size for your requirements. Now, we'll explore the tabs. File. In this, you can open new project, open recent project, sketch, examples, close, save as, print the project, etc. Here you can edit it as a forum, HTML, paste, indentation, that things. Sketch will upload the sketch, you can verify it, export as a binary, verify that things. In tools, you will find a serial monitor, the board, the port and all. Help is for help that will get directed to your Arduino IDEs.org. We'll have inbuilt documentation. So here, this is the thing. Now here, you'll type the code here and then execute it. So once you're done it, basically first plug in the board. Once you plug in the board, there are two main things to be done. First, go to tools and set the board. The board you're using is Arduino Uno. So set this board correctly, and then the port in which the serial communication is going to take place from the system to the board. Correct that port corresponding to the board and name COM3. So press COM3. So with this, you're done now set up the board with your laptop. So now, how to upload a code and how to run it. So basically, there's a if you define examples, so I'm going to file, examples, basics, blank. This is the most basic program. This is the blink program. So now, see here, the void setup, the code is written over here, the looping iterations are written over here. Now, how to upload it and run the code. So you'll see a tick mark over here. This tick mark is for compiling, and this is uploading. When you always remember, when you upload the code, it compiles by default. So when I click upload, it's compiling sketch here, and you can see the status over here. They were running that circle thing, blue one. Now it's uploading. Yeah, now it's uploaded, and you can see the data bits it's used. Maximum of 2048 bits, available bits in the storage space. It has used only 2% of the program space. So with this, you have uploaded a code to your board, and the board performs the corresponding action. As per here, the LED is blinking for every interval of 1 second. So now we are done with the getting started part and uploaded our program successfully to our board. So now moving on. Libraries. As a basic programmer, if you're a basic programmer, you'll know libraries in C, C++. All these things have some inbuilt libraries where you use inbuilt functions, inbuilt sketches, inbuilt the example code that you use. Like in C++, you use apps to find the modulus. So in case even Arduino has lots of inbuilt libraries. For example, when you use servo, you need to include a library called servo.h that takes all the things from the servo.h, and we can access any of the function that we need to use in it. So you can make your own library, download libraries from the net. If you want to import library, go to Sketch. There will be an option called import library as a zip file. Now this is the Arduino IDE. As I told you, there are button bars over here, the input edit area where you write the code, and the status bar done compiling. These things are shown in this. Now moving on. Yeah, it's like the CL port and board, as I told you. It's an important step to be noted. Then using Arduino, coming back. First write your sketch, then press compile button to check for errors. Or you can straight away upload, but it's always recommended to compile and then upload. Then try the blink sketch. That's the most basic thing. So first you code, it compiles, then compiling, applied it, RxTX flashes. This indicates real communication that we'll be discussing later. Then blink, blink, blink. The LED starts blinking interval of 1 second. Now, serial communication, the most important part. How does your programmable board communicate with your computer? It basically works on digital logic. So information passes as high and low variable outputs. So as bits of zeros and ones. So waveform, 1 is high, 0 is low. So if a character is to be transmitted, say character B, the corresponding capital B's ASCII value will be 96. So that will be decoded as a binary digit. That's 0, 1, 0, 0, 0, 0, 1, 0. Each one 0 corresponds to low, 1 corresponds to high. So the resulting waveform will be low, high, low, 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 high and low. So imagine for one alphabet, it's this much wave needs to pass. Then for imagine complex programs, how fast the serial communication takes place between the board and your programming system. So this can be done with the use of digital write and delay commands. That will be we'll studying further. Yeah, compiling turns your program into binary digits, ones and zeros. Okay, so compiling turns your word to ones and zeros, and uploading sends these bits to a USB cable to the Arduino. This is the serial communication starting part. There are two LEDs like RX and TX. RX blinks when Arduino receives data, TX blinks when it transmits data. So with this we can satisfy ourselves that communication is taking place. So basically input output. For what things you can use Arduino to program. Suppose there's actuator that takes the output and that gives us input to Arduino. And Arduino is programmed with a laptop or system. So this Arduino has some commands. So input transducer. So from here the control flows into here, there's something happens and there's output transducer. Like a LED blinking or something happening. Then digital input output. Digital input is binary value. It's either 0 or on or off as discussed before. Now coming to Arduino's digital input output interfacing. There's some inbuilt set of commands that you need to know before going into programming to Arduino. The best things are pin mode, where the parameters pass the pin and mode. Pin is the pin number that I'm going to use, and mode is input or output. The pin is going to give some data or take some data. Now digital read. This is to power out the pin and read the pin's form. Pin's status. You give it as pin number. This reads high or low input from the pin. The basically digital pin 3 will read whether it's high or low and it will return as a string. Like digital write. This is to write the data to the particular pin. So digital write pin comma value. This is to our parameters. So digital write pin of 5 comma high will give 5. It will trigger off. So electronic stuff into this. Output pins can provide always 40 milliamperes of current. It's the main thing to be noted, but this case can be modified using pulse width modulation that we'll be seeing shortly. Yeah, the basic blink program. Now explaining it line by line. Void setup. This is the part where you initialize the pins as input or outputs. So here you're going to use the inbuilt LED as I mentioned before, that's connected to digital pin number 30. So pin mode is 13 comma output. This is going to be an output pin. Okay, so what setup you initialize this. Now coming into looping part. In the looping part, you initialize first digital write 13 comma high. This means I'm powering up pin number 13. Then delay of 1000. This is to be given always in this is like 10,000 say 1000. That means as 1 millisecond. It's like 1000 milliseconds is the unit for this. So basically it will be delay of 1 second. Then digital write 13 low. It will be low for again 1 second. So it will be blinking in intervals of 1 second. Input and output pins discussed before. So input and output pins of digital and analog is only input. You can only give input of signal as analog can only accept as input, but digital pins can give us both input and output pins.